I don't even try to do jokes for that reason. So.
Yeah, I heard that one this morning, and well, I thought I could remember it for 2 hours, and apparently not.
Okay, everybody in place? Everybody ready to go?
Yeah, we should be.
Okay. We're going to try to pick up sort of where we were. You got your recorder turned on, Tom?
Yes.
Okay. We're going to pick up sort of from where we left off on Monday, talking about plants, and we're to the point that we need to begin a discussion with the reproductive component of plants. And plants are such that we don't have to censor this reproduction type thing. So, you sometimes with these other animal discussions, you feel like you need to censor them, but that's not the case here. But as we talk about the reproductive components of plants, we need to have a discussion about what we call a complete flower. And a complete flower is going to contain 4 parts: a sepal, a petal, stamen, and a pistil. And the sepals are the leaf-like structures that encircle the other flower parts, such as in a carnation or a rose. The sepals collectively are called the calyx. I like to use an apple because of my semblance with my background. We growing up with an apple orchard, but an apple closely relates to the flower of a rose as you begin to visualize this. But the calyx portion on an apple, if you look at the little end that's opposite of the stem, you'll see a little brown opening, and you actually can tell, that's where the sepals were, and you'll also see residual bits of the stamens and pistils as you look at the blossom end of the apple. So the petals are the whirl of leaves that come from the sepals. And collectively, the term for the petals is called the corolla. And then we talk about the whirl of floral organs in a complete flower. The male portion in a complete flower is called the stamen, and it consists of an anther and a filament which produces pollen. So as we talk about, the picture of a complete flower, you've got the pistil in the center of it, and the stamen, which contains the anthers and the filaments around that component. And they are the origins of the pollen that we have. As we talk about this, we'll talk also about the carpel, or it's actually the base of the pistil, and that's the central female component of a flower. It's composed of the stigma, which is the receptive surface that receives the pollen, and then it talks about the style, which is the tube that is connected to the stigma, which then is the ovary, which is attached to the lower end of the style. And the ovary in a complete flower is the component or the portion that is going to contain the seed or seeds. If we're talking about the rose or the apple again, the ovary is the base portion of it, and that in an apple, that carpel is actually 5 different compartments that will contain the seeds. And the seeds will, after pollination, will produce growth hormones that will control the way that the fruit will develop. If we're talking about an apple, for example, if there was a problem with the fertilization that existed in the process, the style will carry your pollen tubes down to the carpel, and sometimes there's an interruption or a failure to grow or a failure to fertilize, and you may only have fertilization in 3 of the 5 carpels that exist on an apple. And if that occurs, that piece of fruit or that apple is going to be deformed. It will not grow adequately and will not develop normally. And you'll get a misshaped apple. Sometimes it resembles a sheep's nose or something of that type. So researchers have done a lot of work with the fertilization and so forth with apples and doing that. But all of this is an interconnected process we're talking about with the pollination, providing the pollen to the stigma and the style and eventually the ovary, which is actually the carpel. And there, let me see if I can throw this picture up and we'll look at it briefly. I won't be able to hear you guys, but hopefully you'll be able to hear me. So we've done this a couple of times in my chemical class. So, all right, as we look at this, it's an example of the flower of an apple. This blinking thing keeps flashing. As opposed to the flower of an apricot. Or an apricot or a peach is going to have exactly the same structure. But as we look at this, you can see the ovary in the base of both of these flowers, and the ovules in the apple. There's going to be 5 of those, where with the peach there's only going to be a single because of the way that this is done. The apple, you'll see, has got stigma. There's actually 5 of those stigmas, which will carry pollen down to each one of these ovules inside of the ovary. And the pollen is going to come from those anthers that are held up by the filament. And then you've got the stigma and the style figured there. The petal is going to be that little attractive thing on the background that you see there. I cannot get this thing. This thing wants to update. It's going to do that to me every little bit. Now, the basic difference that we're looking at between an apple and an apricot or a peach flower is the number of stigma that exists. You've got 5 stigma in the apple. You've got a single stigma in that stone fruit or the apricot or the peach. So that's the basic difference that we're looking at. If you think about, I know all of you handled an apple or handled a peach or a nectarine or an apricot. The apple has got the center core in an apple has got. If you cut it horizontally, you're going to see that carpel, which contains 5 openings that each contain 2 seeds. Now, if you do the same thing to an apricot or a peach, that pit is going to be a whole lot harder to cut. But if you cut that, it's going to show a single ovary. And it's going to look very annoying. Very much like the seed from an almond. If any of you ever eat almonds or almond joy or anything, the ovary in a peach, nectarine, and almond are nearly identical. So those are that's the family that we call stone fruits, and the center of that seed is the stone that gives it its name, and it's a hardened case device that is protective of the ovary. Where an apple is not that hard and rigid, but it's a lot easier to cut. But you should, if you cut it horizontally on an apple, you're going to see, if the apple fully developed, you're going to see 10 different ovules or seeds in that apple compared to a single seed from an apricot, a peach, or nectarine, plum, and the same thing. All right, I'll go back so you guys won't be bothered by that thing trying to revise the computer that we're working with. Now, that was a discussion as we talk about complete flowers. We also have a group of plants that have what we call incomplete flowers. And an incomplete flower is going to lack one or more of the 4 parts that we just discussed. It's going to lack the petals, the sepals, the stamen, or the pistil. And those flowers that have both pistils and stamens are referred to as perfect flowers. In other words, it has everything that's needed to perform the fertilization. Now, if we're dealing with flowers that have only stamen and no pistil, they're called staminate flowers. And those that have only pistils and no stamens, they're called a pistillate flower. So the staminate flowers or pistillate flowers are referred to as imperfect flowers because they are missing a single component. All right. Plants that have both staminate and pistillate flowers borne on the same plant are referred to as monaceous. And the example that the book will give you is an alder or a corn plant or a walnut plant. But there are a lot of other plants that that we can call monaceous. The idea of monaceous applies very, very well to the family that we call cucurbids. Your pumpkins, your watermelons, your cantaloupes, your cucumbers are all monaceous. They have a male flower and they have a female flower. If you ever look at those, or if you have any exposure to a pumpkin as it's growing, you're going to see that throw a male flower early in the morning. If you're in the middle of the summer, late June, July, early August, and close to a pumpkin patch, you'll see a predominance of relatively medium-sized yellow flowers on an extended stem, and that's the male flower that exists in that family of plants. And it will open usually pretty soon after the sun comes up, if you've got normal growing conditions. The female flower won't emerge until an hour, hour and a half, maybe 2 hours later, and it will begin to open. And it is, where the male flower was on an extended stem, the female flower is going to be on a larger, more stubby type stem, and you're going to actually see the fruiting body of this, or the small pumpkin at the base of that flower. And what the Mother Nature has contrived a real nice relationship with the formation of these flowers. The male flower comes out first, and attracts any pollinators, bees, bumblebees, or little flies or wasps, to those flowers early in the morning, because these critters are out to accumulate as much pollen as they can, and they'll work through all of these male flowers first and accumulate the pollen on their body parts, their legs, and so forth. And then in about an hour and a half, this female flower opens, and the little critters have already accumulated all this pollen. So now a new flower has emerged, so they bounce over on that and go to working around in that. And in turn, they will fertilize this female flower with all the pollen they collected from the male flower. It's not the type of thing that you'd ever pay much attention to if you weren't interested in plants. But Mother Nature has been pretty astute in what she's done to provide this opportunity. But these plants are called monaceous. You've got different flowers that contain the staminate and pistil parts. This is we're talking now about descriptions of different types of flowers, and I'm not going to hold you responsible for these because they're different. It talks about a chyme and a raceme and a spike and a catkin. They are just different formations of different flowers, and it gets to be a little cumbersome. And for the purposes of this class, I won't hold you responsible for it, but it gives a description of different type flowers that exist from different plants. There's also a panicle, an umbel, a head. An example of a flower with a head type structure is a daisy or a sunflower. All right, as we talk about the next phase after we leave the flowers, we begin to talk about what is a fruit. And a fruit is a matured ovary plus its associated parts. And generally the fruit protects the seeds in some plants, and sometimes it helps to disseminate the seeds. It says many vegetables we eat are actually fruits. So this brings up the debate that people quite often come to me with. They say, Tyler says a tomato, and that's right. Botanically, a tomato is a fruit, but it is classified as a vegetable because of our use of it. But that's just a point of debate that people talk about. But tomatoes and squash and green beans and peas are all botanically fruits. But they are considered vegetables the way we use them.
Is it what generally divides fruit and vegetable, the fact that fruits tend to have sweet taste to them? At least that's what I've always been told.
Well, Tyler, based on just the last 5 minutes of discussion that we had, there's no reference to taste. We're talking about the forms or the botanical parts that we're dealing with. So a fruit is an item or a plant part that protects the seeds. So that's why we're talking about pepper, squash, green beans. Green beans don't have any sweet taste to them, but they're botanically a fruit because the hull of the bean protects that embryo or the seed of it. And that's what we're talking about. Pea is the same way. They're all fruits botanically, but for dietary purpose, they're considered vegetables. Okay? It says flowers of self-pollinated or cross-pollinated by wind. Flowers are either self-pollinated or cross-pollinated by wind or insects. The pollen grows from an individual grain through the stigma, down through the stigma and style to fertilize the egg, causing the fruit to develop. Now, fruits may have a single carpel. That's what we were talking about with the peach or the apricot or the nectarine. Or it may have several carpels, as we talk about with the apples or the tomatoes. And the structure around the carpel is what we call the pericarp. And that's the portion that generally we consume. We don't eat the seeds of an apple, but we eat the pericarp that is around it. Same thing with a tomato, although we generally consume the seeds of tomato, unless you have some dietary problems. I know a lady that used to work here could not eat the seeds of tomato because she had some digestion issues. So, but she loved tomatoes, and she'd get one on a sandwich, and she'd methodically pick the seeds out, and then put the rest of the tomato back on the sandwich. So, fruits develop from a result of pollination.
I actually do have more question regarding the seeds and everything. The pomegranate, what is that? What's up with that thing?
I mean, what's up with it?
Why are the seeds themselves surrounded by that little gel layer inside?
That's a protective thing, and it's also the portion that you consume, that you eat. That's the more edible portion of a pomegranate.
Yeah, the gel seeds.
The gel seed portion of it. But you'll eat the seed also. Pomegranate's it's a tropical thing, and I don't have a lot of experience with them, but I have sold quite a number of them over the years, and it's become more accepted in our area. It's an expensive item if you buy them individually. They're usually in the range of $1, $1.50 a piece. To me, in my eyes, they're not worth it. But there's become a lot of pomegranate juice being. Do what?
Said, good Lord, don't get started on that, please.
Well, no, it's another commodity that's available, but and they're taunting it for different dietary purposes, but to me, it's just kind of sour, vile tasting. But some people think grapefruit juice is that way. All right, simple fruits have a single ovary formed from one flower, and they're categorized as fleshy, semi-fleshy, or dry by texture of the mature pericarp. Fleshy fruits, the entire pericarp and accessory parts develop into a succulent tissue. So we're talking about those simple fruits being the peach and things of that type. All right, here is a visual of a berry. And a berry is a pulpy fruit with one or more carpels that develops few to many seeds. Now, if I were on a test to ask you to give me an example of a berry, would be really interesting to see what you guys came up with. But here, and this is going to be a little different than what you normally consider a berry, but a banana, a date, a grape, a pepper, a tomato are examples of berries.
You said banana.
I said banana.
It's heresy.
It's what?
Heresy.
No. All right. It has a pulpy fruit around a few or many seeds. Now, you're not aware of the seeds of a banana.
Yeah, the little black dots in the center of it.
The little black dots in the center are the filaments or the initial portions of a seed. They didn't develop. Very much like a seedless watermelon. People always talk about a seedless watermelon still has seeds. They didn't develop. You just see the filaments that could have developed were it to have the adequate pollination. But that's why you get seedless watermelons. You don't get the adequate pollination. So, but bananas, dates, grapes are considered berries. So peppers and tomatoes the berry is a pulpy fruit with one or more carpels that develops a few to many seeds. Most seeded grapes will have 2 seeds in there. The wine grapes that we grow, they're all seeded. They'll have 2 seeds inside the portion of that. And there have been a lot of folks that touted the nutritional merits of grape seeds over the past few years. Talks about and I'm horrible with this pronunciation. It's a hesperidum, I think, and it's what it says. It's several carpels with an inner pulp, juice sacs, and vessels enclosed in a leathery rind. And the picture that it's got here is one of a grapefruit. So, but oranges, lemons, limes, and grapefruit are examples of that. You've got several carpels. If you ever try to eat an orange, you'll peel it and you'll separate it, and that individual thing that you separate that you begin to eat or consume is one of the carpels. Some of these citrus fruits are seeded, some are not. Tangerine is another example. Quite often tangerine is full of seeds. A tangelo is another example of this, but they'll have multiple seeds. A navel orange generally has no seeds as compared. You'll get pink grapefruit, which generally have very few seeds compared to a white grapefruit, which is going to have numerous seeds. So, that's and it says the leathery rind. That's the outer protective portion of the peel of the orange, grapefruit, or whatever that might be. So, the next distinction here is what we call a pepo. And it's formed from an inferior ovary that develops from multiple carpels, each bearing many seeds. And the examples of pepo are cucumbers, melons, squash, and watermelons. Those are generally what we were talking about with the monaceous plants. But, we all recognize that cucumbers, generally the edible phase of a cucumber, the ones that we desire, will not have a mature seeds. If you get a cucumber that has a mature seed, it's past the edible stage. But seeded watermelons are a good example. Squash, like the cucumber, if it gets large enough, you're going to find a mature, well-developed seed. And watermelons are that way. Cantaloupes are that way. Honeydews, same way, has that type of seed. And squashes, there's a lot of the pumpkins and the more ornamental type things that we've seen over the last month are different varieties of squash, and they are the product of a lot of plant breeding, and those are relatively easy for a plant breeder to work with because they can do cross pollinations and let that seed develop, and in 6 months that seed can mature, and they'll put it in a greenhouse and have that another generation pretty quickly. The plant breeding of pumpkins has really developed over the last 20 or 25 years in the length of time that I've, from when I used to grow pumpkins to now to when I primarily do the retailing of them.
What was that species of pumpkin that we saw at the Amish auction? They had the stripes on them.
That was another variety of a squash, and I'm not sure exactly what they called it, but it was another variety of squash. It was edible, and I've seen several of those this fall, but I haven't bought any of those. But pumpkins, the plant breeders have been dictated to by the chain stores, the Walmarts and the Krogers and Food Lines and so forth, and they have decided that they want a pumpkin that weighs between 18 and 22 pounds, so it's in uniform size with a long, heavy, dark stem. And the plant breeders have been able to develop varieties that will produce an entire crop of pumpkins in the 18 to 22 pound range. There are other varieties that are going to be from 10 to 15 pounds, some from 15 to 18 pounds, others from 22 to 28 pounds. It's amazing to me that the inroads that plant breeders have made in the past 20 to 25 years. at the desire of the buying public. Of course, there's certain varieties of pumpkins like an Atlantic Giant and a prize winner that had been developed, which will grow pumpkins that anywhere from 400 to 1,500 pounds. There's always an interest in that. When you guys went to the state fair, did you see a large pumpkin down there? Anybody?
I didn't see any pumpkins.
Yeah, we were there like the first day or whatever. They were doing the weigh-in like
Okay.
the next day, so we didn't get to see the good ones.
There was a news article, the news thing that came from Channel 12 in Winston-Salem, that the largest pumpkin that was at the Dixie Classic Fair this year weighed about 1,100 pounds. And they took that pumpkin to the Children's Hospital at Baptist and used it to create a display for the kids that were sick and in the hospital. But they made a huge jack-o'-lantern out of the thing, big enough that I think some of the kids that were a little more mobile could actually crawl up in it and walk in it. So, but it was a huge thing. And back when I was working, playing with pumpkins, I tried growing some of these large ones, and I got a couple that weighed 250 to 260 pounds. But the largest pumpkins during that time, and this was 25 years ago, were coming from an area that I was a little surprised at. Any of you care to venture a guess the section of the country or the world that was growing the largest pumpkins during that time period? No, it's in North American continent.
California?
No, Tyler's saying California. There are a lot of them lately that have come out of, out of Ohio. But back during the time when I was playing with them, the largest pumpkins were coming out of Nova Scotia. Nova Scotia.
Canada.
Yep. They were using a variety called Atlantic Giant, and they would, Nova Scotia has extremely good soil, just really fertile loam soils, and they would take a couple of acre field and put maybe as many as 3 or 4 plants on a single acre, and they would build a little small protective greenhouse over the initial plant. They plant it early, and then they would control the temperature in there so it would stay warm at night because of this little greenhouse that they would fix. And it'd be 8 feet by 10 feet with 5 foot high. And the reason that they were so productive and efficient with that is they had extremely long days. If you ever think about it, that's in the northernmost portion of this hemisphere. And I was in Nova Scotia for a period of time one summer, and the sun would be still up and visible and providing adequate illumination to do anything you wanted to do at 10:30 or 11 o'clock at night. And then it would come back up after a little period of dark. It would come back up between 4:30 and 5 o'clock the next morning. So the long days allowed for maximum photosynthetic activity under this unique set of conditions, and they would only allow one pumpkin to develop on an individual vine. So all of the photosynthetic activity and the carbohydrates that were produced went into that single pepo type of fruit. And to me, it was always interesting the way that they were able to do that. Another category of fruit that we talk about is a drupe. And drupes are simple fruits derived from a single carpel. And this is what we were talking about a while ago with with the peaches, plums, apricots, an almond, and an olive are all examples of drupe type fruit. You've got an exocarp, which is the outer layer, which becomes the skin. You know, if you peel a peach, you're taking away the exocarp. And you take away the exocarp to get to the middle layer, which is the mesocarp, which provides the thick, fleshy, edible portion. And that's going to be true with the plum, the peach, the cherry, the apricot, not the almond. You don't want to eat the mesocarp of an almond. Now, some people consider the mesocarp of an olive as edible. I'm not real crazy about many olives, but that's what we're talking about. And then the endocarp, that's the inner layer that becomes the hard, stony, what we call the pit of a drupe fruit. So the endocarp is the seed of a peach or a cherry or an apricot. He says quite often that the pit is referred to as the seed, but the seed is the ovule that is in the center portion of this endocarp. So if you, some people have in this area that raised hogs would process peaches in the summertime, and they would take the pits and the peels and so forth and toss them over into their hog lot. And the hogs will pick up these individual seeds and crack them and eat them. And if the hog is not large and strong, and he does much of that, quite often he'll get sick because there's some undesirable compounds that are in the center of a peach seed. There's some toxic materials in some of those. So that's just a word of caution if any of you ever had to do that. All right, as we talk about another category that's here, we mentioned it a while ago, a pome fruit is a simple fruit that has several carpels, and an apple or pear are examples of that. The outer, the edible portion is what we consume, and the center portion has multiple carpels. When I first went to Tech, there was a class that we had that was called pomology. Pomology, it was a study of pome fruits. We studied apples and pears and primarily. We've got another one that talks about descent fruits, which fruits split or dehaze at maturity to expose the seeds. A milkweed is one of those. A legume or a pod, they are your peas and beans. They're fruit from a single carpel, which usually separates at the seams. That's, if you're familiar with peas, that'll separate, and the seeds will emerge there. A capsule is a fruit that forms from 2 or more carpels and produces many seeds. A poppy or Jimson weeds are examples of a capsule. A follicle are fruits that form from a single carpel that splits along one suture. A delphinium or a helleborus flowers are ones that have follicles. A couple of these I'm gonna skip over, but an acheme is one that I think we need to include. It's a simple, one-seeded, thin-walled fruit attached to an ovary wall. Achemes are often mistaken for seeds, such as in the strawberry. The so-called seeds of a rosehip or sunflower are examples of an acheme that we talk about. We're out of time, I just looked, so we'll pick it up here talking about the Caryopsis and move forward when we get back together on Monday. We'll have class on Monday, and then you guys get to enjoy turkey. So,
Woohoo. All about the turkey.
yep.
Yeah. Thanksgiving meal, that's almost as good as Halloween candy, so.
Yep. We've got about 4 or 5 more slides, and then we'll finish up this chapter. So we're getting along okay with it. And
Okay.
this way, maybe we'll be able to have chapter 6 and chapter 7 on this last test. So
And for
it
the
won't
record,
be too bad.
I don't know what you managed to do, but we were actually able to watch your slides the entire time, and you were able to.
Well,
apparently, so.
that's what I was trying to do, and you know that it works for you to see them, but I can't interact with Carol and Caitlin. If they fuss at me, I can't hear them. So.
But apparently you have been hearing us today, so not that they said a whole lot, but.
Yeah, it's worked. I switched back, after that.
Yeah, well, I mean, we were still seeing your screen. We were seeing it before you started hitting the buttons, and then even afterwards. So we saw you the whole
Okay.
time, so.
Well, whatever. It's just this is sort of a mysterious system at times.
Yes, it is. Hit it with a hammer and keep on going.
There you go.
Yep.
Thanks, Tom.
Yep. Okay, bye, everybody.